first when dividing fractions? What do you do first?
You can do the common factor.
Okay. Step one, though. What's step one when dividing two fractions? Flip. Good. That's the word I was really looking for. Flip the second fraction and multiply. I agree we could do some simplification, but most important is that you flip and multiply. Now, of course, you could just multiply across the top and across the bottom, but because of what we're about to do, which you've done it before on the toolbox, I'm going to go ahead and do as much simplification as I can before I start. I'm going to look for common factors. Do you see any things with common factors? Okay, the 9 and the 6, or the 6 and the 15, whichever one you saw first, it doesn't really matter. I can divide a 3 out of both of those and I get 2 over 3. That's it for common factors, isn't it? Because we have to have them on top and on bottom. So this is negative 8 over 45. If you are doing this completely without a calculator, would you agree it's easier to simplify before you multiply? I know that you think you will never be without a calculator, and you probably won't. However, there are a few companies in the world who still do aptitude tests when you go sign up to work, and a lot of those will be math without a calculator. So you never know where you might encounter something crazy like that. All right. So the goal of the day will be to multiply and divide rational expressions. We learned that a rational expression is a fraction, a polynomial on top and a polynomial on bottom. So before we actually work with multiplying and dividing them, we're just going to talk about simplifying them. And remind me, what am I going to have to do to simplify a rational expression? I've got to factor. If you have not figured it out yet, factoring is one of the most important algebraic skills that there are. That is why on our very first mastery exam, factoring was a big part of it. If you cannot factor, you are in big trouble. You can't do polynomials. You can't do rational functions. You can't do just about every chapter has something that you miss if you can't factor. Now, of course, I've given you a program that should be foolproof, but if you don't know how to factor, you need to work on that. If you can't get those to factor some way, calculator, non-calculator, somehow, you have got to make that happen before the college algebra final. So work on that. Factors of 4 that add to give you 5. 1 and 4. Factors of 20 that add to give you 9. It says simplify and state any restrictions. I do want to talk about restrictions before I do any simplification. A restriction is something that A cannot be, very similar to a domain problem. What can A not be on this fraction? Negative 4 or negative 5. Okay. I always want you to be able to pick those out. The point of what we're doing today and tomorrow is to get ready to solve rational equations. And one of the things you'll have to know when you're doing rational equations is what A can't be. So even if it doesn't ask, make sure you can always pick that out. The A plus 4s cancel, do you agree? And you're left with A plus 1 over A plus 5. Go ahead. Any questions on that one? Good. Okay. How do you factor something that looks like this? Did that answer your question? Are you sure? Okay. What about the next one? How do I factor the next one? What's the first factoring technique I always use? Greatest common factor. Is there a greatest common factor? 2a. Bottom, is there a greatest common factor? What can A not be? -5, I agree. And what else? Why 0? Good. 0 times anything makes a 0 on the bottom, so A cannot be -5 and A cannot be 0. What simplifies on this one? What cancels? A plus 5's cancel. A's cancel. And I'm left with just 2/3. It was A plus 1 over A plus 4. Think numbers for a moment. If A is 3, 3 plus 1 is 4, 3 plus 5 is... Does that make sense? So only if it's multiplication can you cancel. All right, let's look at this one. Multiply or divide. So now I have two fractions. What am I going to do first? I'll make those a little bigger. What am I going to do first on all of these? Okay, on the ones that are divide, I'm going to flip those first. I agree. What about the ones that are multiply? What should I do first? Factor. That way I can see if any factors cancel. Is there a greatest common factor here? What is it, 7? Okay. Does anything cancel? Almost, right? The b minus 4 and the 4 minus b are very, very similar. What could I do to make them cancel? Good. Instead of taking out a positive 7, could we have taken out a negative 7? You might not have noticed that at first, and that's okay. But if I now do that, don't I get b minus 4 on top and bottom? And so I get -7 over b plus 10. What do I need to do on the next one? It is multiplication, so I don't need to flip. What do I need to do first? Factor. Does x squared minus 16 factor? Good. X plus 4, x minus 4. It's a difference of perfect squares. You do have a note card on factoring, or you can get really good at your calculator. You've got options. X squared plus x minus 90. What are the factors of 90 that subtract to give you 1? Multiplies to give you 90 and subtracts to give you 1. Good. So x plus 10, x minus 9. What are the factors of 40 that add to give you 14? Good. That's a 4, not a 9. All of this other being said, what do you think I should probably do with the 9 minus x? Especially looking at this x minus 9 up here. Factor out a -1, which causes that to be -1 times x minus 9.
So you can cancel on both sides.
Mm-hmm. Yep. Anything that's on top can cancel with anything that's on the bottom. So the x minus 9s are going to cancel. The x plus 4s are going to cancel. The x plus 10s are going to cancel. Which leaves me only with x minus 4 divided by -1. Or I could write that as -x plus 4. You okay with why I could write it as -x plus 4? Just divide both pieces by -1. Any questions about that one? You could do it either way, but I would recommend flipping first because most people who don't will forget. Why is he talking about flipping? I agree. Why is he mentioning flipping? It's division, and that's how you divide two fractions, is to flip the second fraction. He asked if you have to do that first. Technically, no. If you can flip and factor and do all of that at the same time, that's great. But make sure you flip the fraction very early on in the problem, or you might forget to do it. Always the second one. Is there anything that factors? 2b factors out of that first piece. The b plus 5s cancel. The b minus 6s cancel. And I am just left with 2b. Any questions about that one? So this is the second time you've seen this in this class. Is it easier this time than it was the first time? That was my goal, as you can imagine. When you flip the second fraction, it becomes multiplication. And the reason that is, if you think about it with numbers, Kyle, dividing by 2, isn't that the same as multiplying by a half in real number-wise? And so that's what we're doing. We're using that principle that division by a fraction is the same thing as multiplication by its reciprocal. So again, you can do more than one step at once if you want, but the very first thing I'm going to do is flip that second fraction. Did everyone understand my 1/2 example? Dividing by 2 and multiplying by a half are the same thing. Example of that, if I have 8 pieces of a candy bar and I divide that into 2, I get 4, right? Or if I have 8 pieces of a candy bar and I half it, I get 4. It's the same. It is the same operation. Multiplying by a reciprocal and dividing by a number are the exact same operation. 5p squared factors out. Does everyone agree? And I get p minus 7. What about on the bottom? A 9 factors out. Does it mean I did something wrong that these aren't the same? No, they may be, they may not be. The 5p squareds cancel. Does everyone agree with that? And even if the 5s weren't the same, the p squareds could cancel. In this case, they both have a 5. But so I get p minus 7 over 9 times p minus 4. Any questions about that? You are correct. Did everyone hear Caitlin's question? She asked, could you write it as 9p minus 36 on the bottom? Yes. Those are completely equivalent. Typically, if you've already factored it, it's easier just to leave it factored and a little bit more useful in different ways, but they are completely equivalent. Do I need to flip this one? No. So I just start factoring. Lots of greatest common factors on this one. X, x minus 2, 40x squared, x minus 2. Am I going too fast? Okay. $16x squared. How many times does 16 go into 80? Yeah, 5. You're right. Okay. Quick question. How many of you saw a 4 and not a 16? How many of you would have probably tried a 4, not a 16? How many of you didn't know that 16 went into 80? If you did that, I just want to show you what that would look like. You would end up getting 4x plus 20. At this point, look again. Do 4 and 20 have anything in common? Then just take 4 out. So just try again. So just mental note, sometimes we may not catch the greatest common factor the first time, and that's okay, but kind of do a little self-check and see if it was in fact the greatest common factor, if you could go factor that any farther. Just mental note. The x plus 5s cancel. The x minus 2s cancel. What else? The x squareds cancel. Anything else? What about the 10 and the 40? This x squared with this x squared. But I did not get rid of that x yet. What about the 10 and the 40? It can simplify to a fourth. There's more that can be simplified, but I'm going to pretend I don't see it. So on top, I'm left with 16x, and on bottom, I'm left with 24. And if you had not seen the other part, you would have just had 160 over 240, 160x over 240, which would be fine. And now I'm going to simplify that fraction to 16/24 simplify. And if you get stuck on that, how could you do that? Calculator, you could type 16/24 math, enter, enter, and it would reduce it for you. What divides out of both 16 and 24? 4 does, so does 8. So 2x over 3. If you type 16/24 in your calculator, it'll tell you it's 2/3 if you use math enter, enter. Okay. What do I do on the next one? Flip it first. And remember, when you flip it, it becomes a multiplication problem. Factor. N plus 9 has nothing that factors. What about the 3 and minus 18? And what about the 6 minus n? Take out a negative 1 and you would get n minus 6. There are a couple of different ways you could write this. You could do negative 3 over n plus 9, or you could do 3 over negative n minus 9. Those are both correct answers. Just depends on where you put that negative 1. Everyone know what I mean by that? You could either do 3 divided by negative 1 and get negative 3 over n plus 9. Say that again. The negative 1. I factored it out of 6n, 6 minus n, to make it negative 6 and positive n, so that it's with n minus 6, just like that top one. Anytime they're written backwards in subtraction, we're going to play that same trick. You see up here how we did that same thing. All right, any questions? I'm going to pass out your homework, and you do have time left. You